Hello everybody. It's been a while since I made a video, but weather's been crappy. For the past several days it's been overcast, and it's projected to be overcast for the next several days. However, one of the interesting things about getting into astrophotography and astronomy, which they're, let's face it, they kind of go hand in hand really, is that even when you don't have any sky and the weather's not cooperating, you can't make any observations, doesn't mean you can't revisit the observations that you've already made. And as I've learned over the last couple of weeks, some of the observations that I made a year ago, I can go back and revisit those and apply new skills I have learned to the data that I captured back then, and improve on the pictures that I originally created. And another new skill I've learned recently also is it is possible to take observations made on multiple nights and combine them into one large stack of observations that can also be processed to try to improve your images. So having said all of that, I have attempted to apply these new skills. Since the weather is so bad I can't make any real-time observations, let's go visit observations I've done in the past and see what they look like when I apply some new skills I've learned to them. And so toward that end, what I've done is I've chosen some observations I did back in February of 2024, which are, or is, I should say, the Andromeda Galaxy, one of the most commonly photographed deep sky objects, and a deep sky object that is available even if you have light polluted skies, and even if you have limited skies certain times of the year. During the winter months, or during the winter season, Andromeda is available quite often very high overhead. So even if you have limited sky in your backyard, you can more often than not find some time to catch Andromeda overhead and do some observations. So anyway, I have a few nights of observations of Andromeda. Let's have a look. So this is my astrophotography folder, and M31 is the Andromeda Galaxy. I made observations on the 10th, 17th, 22nd, and the 29th in 2024. I'm going to combine two nights. I'm going to combine the 22nd and the 29th. I could combine all four, and I may do that as an experiment in the future. But for today's experiment, I'm going to combine just these two nights, mostly because on each of these two nights I did do darks as well as lights, and on these two nights I did not. On these two nights I have lights only. What that really means, for those who don't know what that means, is when you start getting into astrophotography, you're going to learn that in addition to simply just taking pictures of your object and taking multiple pictures of your object, and taking those in a raw format. I mean, these are things that you'll learn as you get into astrophotography, but in addition to that, you also will take additional pictures to help calibrate your camera or your telescope, or the combination of the two, depending on what you're using, but to help calibrate these sensors and errors that can creep into data that sensors can introduce. There are ways of taking pictures with the camera you're using to do your observations to create what are called dark frames, which basically involves just simply covering the lens of the camera so that the camera's completely in the dark, and taking several frames of pictures at the same exact exposure that you took your light frames in. It's extra work that I really wasn't aware how important it was until I started to get into this hobby. But I have learned how to create darks that match my lights. I've also learned that you also need bias files and flat files, and those are something I have not created yet. I'm not sure how important it is to do those when you're using a simple smart telescope the way I am. Maybe someday I'll figure out how to get those done and use those also. But for now, I'll be using the light frames that I've shot, and where I have them available, I'll use the darks also for the processing. So what I will do is I will combine the data from the night of the 22nd with the night of the 24th into a folder that I have labeled as multi-nights. There's a process to do this that you go through to create a multi-night stack, and I'm not going to bore you with the details on how that's done. What I will say is I learned how to do this by watching YouTube videos, and in particular this guy's channel. See if I can show where that is. Bear with me. Oh, here's the exact video that I used. Sorry, there we go. Right, Deep Space Astro. I am a subscriber to his channel, and I use this particular video, stacking multi-night data in Siril, to do what I am showing you what I'm doing today, which is combining stacks from multiple nights into a single stack that I can then process. So anyway, those who are interested, I have found Deep Space Astro. Let's see, here's his channel right here. This guy's channel, very, very, very helpful in educating me on how to more properly use Siril to process your astrophotographic pictures. So anyway, I did want to give a shout out to this guy and his channel, and thanks so much for posting your helpful videos. I'll be diving into way more of them as time goes by. Right now I'm still trying to get into the basics. And one of those basic skills would be learning how to stack multiple nights observations. So I have done that. Anyway, having said all that, let's show how that is done. I've created the stack that I need to create, and I have placed the light files in the working folder that I'm going to be using. I am using the latest version of Siril, which is 1.4.0 RC1 as of this point in time. So when you have created a stack of multi-night images, you can do the simple form of processing, which is the processing without darks, without biases, without flats. Since we've created a whole brand new stack that was based on the original observations, we're not going to need the calibrating frames. So this is the process we will use in Siril, and I will verify that I do have the correct working directory, which I do, and I'll run that script. And as I recall, I think this resulted in it tells me right there, 321 files. So the final stack is a stack of 321 that are going to be processed by Siril to result in a resulting FIT file that will give us our final image that we will then work on with some of the other new skills I've learned recently to see how good of a picture I can create out of it. So this process will take some time, and I'll be back. Okay, so my first attempt at processing the multi-night files have resulted in an error. So the script stopped running, and it gives me this error message, which is in red. Not enough space to save the output images aborting. Basically what that means is my working directory, which is my C drive. I'm using the C drive because it's the very fastest drive I have connected to my computer, so it makes all the processing faster. It unfortunately does not have enough space. The space required to do this processing on your hard drives is enormous. In this particular case, I think my hard drive had more than 100 gigabytes of space free, and that still was not enough. So, what this means is I will have to transfer this processing to one of my larger, slower hard drives, which will make the processing painfully longer. However, it will get done. So that's what I'm going to do now. I'll go through the process of specifying a different working directory and moving all the files there, and I'll start this process all over again. I'll be back. Alright, so I have moved the files to my next quickest hard drive, which in my case is the E drive, is now my new working directory. So we will now attempt to run the without DBF processing on my multinight stack again. And here we go, and I'll be back. Okay, so yeah, I came back fairly quickly because, yeah, I've come to the realization that, wow, this is going to take a long time. Here's why, though. Let me talk about that a little bit. So when you get into astrophotography, you will discover that your file sizes explode. And the amount of hard drive space you need to record your observations and then also record your processing that you have to do with the files requires an enormous amount of hard drive space, something I ran out of about a month ago, and so I upgraded my hard drive space to accommodate this new hobby. I'm now rocking a 24 terabyte hard drive, which is 1/3 full. Yeah, but it has more stuff than just astrophotography on it too. But anyway, having said all that, so this particular stack of files that I'm currently processing comprises of 321 separate observations. So it's 321 image files. I guess astronomers would prefer that you call them data files, but to me they're still pictures. But anyway, there's 321 of them that are being processed. Now these are raw photographic data files. Raw files is something I learned about a long time ago, about 2007, when I first got into digital photography. Raw files, if available on your camera, is the best file format for you to shoot in. It literally records every pixel that the sensor records on the camera into one giant file. So it's way more information than just what the picture that you're looking at through your viewfinder provides, which is what makes it ideal for astrophotography. You are literally collecting light that has come from far away onto a sensor and recording all the information you can about that allows for all of this processing that you can now do with the data after you've recorded it. So anyway, these 321 FITS files that are currently being processed, that one stack, that comprises 30 gigabytes of data. While that's being processed, a process folder is being created to process these files that may require double or triple that size. Now this is a folder you can delete once everything's all done, but nonetheless, the amount of hard drive space you need to do this kind of processing is really big. So I just kind of wanted to get on and explain a little bit about that. And since I'm now copying to a slower hard drive that has a lot more space, but it's a attached hard drive, which means the data transfer is much slower, this process is going to take 10 times as long as it would if I was doing it on my C drive or my SSD drive. But hey, it's the way it goes. Maybe someday I'll upgrade to a giant computer with a giant SSD on it. will eliminate some of this time problem. In the meantime, while this process takes place, I got other things I can do. So I'll be back. Holy crap, not even a third of the way through yet. Almost a third of the way there. All right, so finally the stack has been processed into one finished file. The process took, if we look down here, total execution time, 2 hours and 48 minutes of not being able to touch the computer. Because the more you touch the computer, the slower the process would run. What this highlights, 2 hours, 48 minutes, if you're looking for a new computer today, buy as much SSD storage on your computer as you can possibly afford, or more than you can afford. You will eventually someday need it. And SSD performance, if I was to have done the same process on my SSD drive, this would have taken less than 15 minutes. But because I had to offload the process to an external hard drive, that 15 minutes became 2 hours and 48 minutes. Damn. Anyhow, that process is done. And so now we can look at the end result of that process, which is this file here, result.fit. Let's put that into our Siril editor. Ta-da! There it is. Yeah, it doesn't look like much, does it? And that's by design. That's how this software works. We are looking at this data in the linear mode. Before I stretch any of this data, we can look at it in a stretch preview mode, which is called auto stretch. And there's a better picture of what I got as a result of stacking 2 nights worth of views. This is the initial data. This, of course, needs a whole lot of cleanup and processing done to it to really bring out the full picture of the galaxy, and I'm about to begin some of that process now. One of the first things that I'll do, which I've learned recently, is to have a look at the histogram view, and this will give me an idea of where best it would be for me to make crops, because you do want to crop out all the artifacts that occur along the edge of your image for various reasons. But anyway, a typical crop on stacks like this is something like that. I'm going to crop that out. Okay, and now we'll go back to the linear view. Okay, actually, let me go to the auto stretch preview, and at this point I do want to activate the background extraction. This is going to get rid of the green that you see, along with a lot of other noise and stuff. But anyway, here's how this process works, which I did a video a few weeks ago where I was showing this same tool and explaining how I was using it, and apparently I was using it wrong because I was applying this to the linear data without doing any screening. But I've learned now to instead perform this on the auto stretch view, and after generating these sample boxes, I'm going to want to eliminate any samples that look like they have a star in or touching them. So I'm going to look through each one of these squares and see if I need to eliminate any. I also want to eliminate ones that are near my object of interest, which is this very large screen-filling galaxy, Andromeda, also known as M31. Let's get rid of a bunch of those. And now let's look at all these other ones. Give them like this one here. I need to get rid of that one. You get rid of squares by right-clicking on them. If you wanted to add a square in, you could left-click one, literally anywhere you want. In this case, I'm just going to go through and eliminate any squares that are containing any stars. So bear with me while like that one's kind of touching one really close. And I am satisfied with that, and once I'm satisfied with that, I will click on Compute Background. And wow, what a difference that makes in the image. Let's apply that. And wow, okay. So I can say, just from having worked on this object in the past, I'm already seeing more detail than I usually get out of my observations just by stacking these 2 nights together. This is pretty cool. Okay. There are several things I can now do to this to try to make it look even better, and I'm going to try to do some of those now. One of the first things I need to do is go to the tools and go to astrometry. I think that is how that's pronounced. Astrometry. I need to do an image plate solver. In fact, there's what it says, flipping image and updating astrometry data. It's the updating astrometry data that I'm really after. Flipping of the image really just makes it look the way it should, orientation-wise. But the astrometry data is the data that will help me to color correct this image. And that's done with the color calibration process by going to photometric color calibration and just taking the defaults and clicking OK. And the process will now run to do the color correction on this image. And when it's done, there we have now color corrected the image. And at this point, I will now separate the stars from the non-star objects. We'll do this with star processing. Oh, there is one more thing I do want to do before I remove the stars. I want to go back to the linear view, and I do want to desaturate any stars that are oversaturated, and I'll do that with the desaturate stars process by clicking that right there. And that executed very quickly. And in fact, it reports that 0 stars are desaturated. That's a good sign, actually. Cool. Okay. So, having checked on star desaturation, go back to my stretch view. At this point, I am going to separate the stars from the object by going to StarNet Star Removal. And the defaults are what I want to go with, and I will execute that. And this will take a few minutes to run. So I'll be right back. Okay, and as you can see, that process has completed, and it presents me with the Andromeda Galaxy and this satellite galaxy here, which I do apologize to astronomers out there. I should know what that name of that is, and I do not. Sorry. But it is one of the satellite galaxies near Andromeda that we can see. Notice how all the stars have been removed. So there's some additional adjustments that I can make this picture, try to make it look better. And I'm going to start doing. We're going to start with some stretching. And the first stretching I'm going to start with is the histogram transformation. And the very first thing I would do is just drag this back and forth a little and see what effect that has on my image. Notice the more I get it intersecting the actual data, the more the image brightens up for me. I'm going to apply that, and now I'm going to stretch it some more. I'm going to take this one on this side and drag it over here, close to where the graph starts, making sure I'm not increasing any clip numbers. And let's drag this one a little bit more towards it. I don't want to blow out the center area here too much. But I would like to brighten up some of this stuff out here too. That's not looking too bad. I'm going to apply that. And now I'm going to go to another stretch at this point. I'm happy with that. Let me see if I can get anything to come in a little better with the generalized hyperbolic transformation. This one will allow me to do a couple of things. The main thing is it's going to allow me to just select a specific area to have it focus its stretching on. I'm going to go with like this outer part here and see what I get. Yeah, it brightens that up a bit. I like it. I'm going to apply that. And maybe let's give it just one more. Just some of this out here, maybe. See if I can bring any of that in. Some more. Okay, it's starting to blow out the center too much. I don't want to increase that too much more. I'll apply that and close this. And the next thing I'm going to do is I'm going to run a script. I'm going to run a Python script. The purpose of this is to add some more detail to this object. I'm going to do this with the HR multiscale Python script. Let me run that. There we go. So we got the HDR multi-scale tool up and running. Let me fit the preview, and I'll zoom this in a little bit and see what this tool will do for us. Let me hit the preview button, just taking the defaults. I don't know if that did me much good here or not. Let's see, show the original. Yes, it did. Preview. Okay, now I think if I reduce the scales, bring the max gamma down, I can soften that glow in the middle, right? Yes. Yes. Let me show the original. Okay. Preview. Look at the preview again. Wonder what adjusting the compression will do. This has something to do with the luminance, or let me see if I get a clue here. Let's see. Yep, just gives me the strength. No, it's a little rough. I'm going to take that right there. Let me apply to Siril, which is okay. Wow. That looks good. Nice. Okay. Try one more thing here. I don't know how much color's in this image, but let's enhance whatever color there is. I'm going to do that with the color saturation. Let's try just a global. I want to, whatever colors are in there, let's saturate all of them. Now this is a tricky one. You don't want to give it too much, but it's not looking too bad. What if I turn the background down a little bit? I'll bring that back up a bit. I like that. Apply. Alright, let's see. Is there anything else I can do to this before I merge it back with the stars? I know there's a couple of more scripts I could try running that I don't think requires the separate images, but anyhow. Alright, so at this point, let's go ahead and save this image. And now I'm going to bring the stars back in. And I'll do that by activating the star recomposition tool. You load the starless image you just created into this box here. And there it is. And then in this box over here, we're going to bring back the stars. Boom. And I'll make a decision on whether the stars need any boosting or not. And geez, I don't think they do. This is my opportunity to boost the stars if I wanted to, and I would do that with this stretch factor here. Do I need to make them any brighter? No, I don't think so. I think I like the brightness. Well, maybe a little bit. I mean, just give it a touch. Looks good to me. I'm going to apply that. I will now close. Now let's try these two new Python scripts I was just turned on to recently and see how they work on this image. Go to the Cosmic Clarity Sharpen script. Run that. I want to do both. I want to do stellar and non-stellar both. and I'll hit apply. Okay, sharpening progress is happening. Just using the default settings here to see how it works. Okay, and the cosmic clarity sharpening process is completed. Let's have a look at the before and the after. So here's the after. There's the before. So you have before, after, before, after, before. Yes, it looks better in the after image. I don't know if it looks sharper, but the image looks better, which is kind of the point. I just took the default settings. I'm not going to play around with those right now to see if I can make this any better. I'm pretty happy with how it's looking. The next script I want to try that I've never tried before is the denoise script. Cosmic clarity denoise. Let's give that a go. Run that one. Okay. I'm going to turn it down a little to, let's try a .41 on the denoise strength. Change to full. Hit apply. And the denoise process is starting. And it's about done, and let's see what we got. Boom. Nice. Close that. So here's our before picture, and then here's our after doing the denoising. Really lit up the galaxy nicely. I like this. I like it a lot. Is there anything else I really want to do with this? I'm not sure if a little let me just have a quick look at it, just an overall stretchy here. Let's see. See what I like. It seems to be brightening up. I think I like that. It's going to be the last stretch I'm going to apply. Okay, that is basically it as far as the editing of this image I'm going to be doing in Siril. I'm going to call that work done for now. So I'm going to save this as a fit file. I will also save it out as a PNG file for me to do some further editing on. Okay, so at this point I'm going to save this, save the results of all my work out as a couple of different files. First I'm going to save this out as a fit file. Whoops, before I do that I want to put it into linear view. We put that linear view to save as a fit file. Save. And we'll replace the existing one and save that. Okay, now that I've saved that out as a fit file, let me go back to the auto stretch view. I will save this view out as a PNG file, which it does to my working directory. So if I go to my working directory, here you see the result of the stack processing. Here's the result of the starless processing. Here's the result of the star mass processing. These two pictures recombine to create this picture, which I saved out as this file. Here's a PNG file that represents a usable picture of what that looks like. Very nice. I mean, I really like the results of this. It came out better than any picture of Andromeda I've done so far. I've done about 3 or 4 different attempts at Andromeda, but this is really good. I'm going to make it even better by removing some more of the background with a new tool that I was introduced to called Affinity. So let's give that a look. Let me close this one, And what I'm going to do is open this PNG file with Affinity. Affinity is free software, believe it or not. All you have to do is open an account at Canva for free, and they will let you download the software for free. I suppose there must be some catch, but I haven't figured out what it is yet. So far, I'm liking this software, especially considering the fact that it's free. So I've got this PNG file loaded into Affinity, and I will use the Affinity Astrophotography Remove Background tool. So with this tool, I take this little circle here and place it somewhere on the background where there are no stars, preferably the darkest point maybe. I'm going to go there and I'm going to click on Sample at the Handle Position. And look at that. That's just using the default settings. I think I will play with this gray knob and see if I want to lighten this any further. See how that works? I'm going to stop it right about there and apply that. And yeah, let me save that out. I'll just take the default name for it. I'm happy with that. Yep. And here's the resulting PNG file. Let me blow that up a little bit. And there you go. There is a picture of the Andromeda Galaxy that is based on data that was collected from 2 different nights. That has been combined into one data set and processed. Anyway, hope you enjoyed that. It was, I'm sorry, it might have been a little difficult for me to get through, but hey, it was my first time at it. But I'm very happy with the results. I'm very pleased with these new skills that I've learned and learning more and more how to better apply them. So I think what this does show, or what I would like to point out, is that in astronomy or astrophotography, if the weather is bad and you can't get the telescope out, you can't make any observations, you can go back and revisit any of your old observations and breathe new life into them with any new skills you have learned since you've taken them. I have a bunch of old observations that I'm now going to go back to and revisit and try to make better pictures out of them than what I originally got. Part of the fun of this new hobby. Anyway, that's it for now. Ta-la!